Welcome to Exercise Explained. So, today we would be doing question number 5 onwards for this video. Question number 1 to question number 4 of exercise 1A, Force ICSE 10th, has been done in the previous video, the link for which will be given in the description below. Do share it with your friends and consider subscribing to the channel. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively. So one force is acting upward, another force is acting downwards at the two ends A and B of a uniform rod of length 4 meter. So there's a rod AB, as you can see in the figure here. So there are two forces 10 Newton each. So one is acting upwards from A and another one is acting downwards from B, which is pivoted at its midpoint O as shown in figure. So the center is O, it is pivoted here. Determine the magnitude of resultant moment of forces about the point O. So we basically need to find the moment of both the forces about the point O. So here what I would do is total moment of force will be moment of this force, that is Fa about O plus Fb about O. So in the first part I find out the moment of Fa about O, that is Fa into distance from O, perpendicular distance from O, that happens to be OA, plus in the second part I will be finding the moment of Fb about O. So that's going to be Fb into perpendicular distance from O, that is OB. So we can write it as Fa into OA plus Fb into OB. So Fa is given as 10 newtons into OA is given as 2 meters because the total distance is 4 meters and it is given here midpoint O. Midpoint means it will be at a distance of 2 meters. So OA will also be 2 meters and OB will also be 2 meters. So here 10 into 2 plus Fb into OB, so that gives me 10 into 2 again. So 10 into 2 is 20 plus 10 into 2 is again 20. So 20 plus 20 gives me 40 Newton meter. Now let's talk about the direction. So you can see here Fa will be rotating about O like this. So you can see here it is going to be clockwise, as well as this Fb will also be rotating about O like this. So this will also become clockwise. So since both the moments are clockwise, we will write the direction also as clockwise. So getting into question number 6, ICSE 10th force exercise 1A. Figure shows two forces, each of magnitude 10 newtons. So there are two forces, one is Fa that is equal to 10 Newton and Fb that is also equal to 10 Newton, acting at points A and B at a separation of 50 centimeter. So these two, separation between these two, that is the distance between these two, is 50 centimeter in opposite directions. So you can see Fa is going upwards, Fb is coming downwards. Calculate the resultant of the forces about the point A and second one about the point B. So you can see here I have written A as here and B is here. So Fa is acting from A and Fb is acting from B. So we need to calculate the resultant moment of the two forces about the point A. So first thing we need to find is about A and then we need to find about B. Now what would be the perpendicular distance of this Fa from A? It's going to be 0. The reason is this one is originating itself from the point A. So the perpendicular distance is going to be 0. So if we take the moment of this force Fa about the point A, it's going to be FA into 0, because perpendicular distance is nothing. It is starting from this point only. So when it is starting from this particular point, we should understand that the perpendicular distance is 0 because it is acting on the point itself. So total moment of force is going to be FA into perpendicular distance between FA and O, sorry, between FA and A. So that's going to be FA into 0 plus, here we have FB. So FB into perpendicular distance between A and B. So this is going to be 50 centimeters. So FB into 0.5. Now how did this 0.5 come? 50 centimeter is nothing but 0.5 meter. 50 by 100. We divided by 100. So 50 by 100 gives us 0.5 meter. So FA into 0 plus FB into 0.5. So that gives me 10 into 0.5. So 10 into 0.5 gives me 5 Newton meter, and that's going to be clockwise because this is acting like this. So it will be rotating about the point A like this. The way my mouse is rotating, it will be rotating like this. So it's going to be clockwise. So FA into 0.5 gives me 10 into 0.5 gives me 5 Newton meter clockwise. Now coming to the next one, that is at B. So the perpendicular distance between FA, that is this force, and B is 50 centimeter. So we write it as FA into 0.5. Again 50 centimeter is 0.5 meters. So FA into 0.5 plus FB into 0, because again FB is acting about B only. So there is no perpendicular distance. So we take it as 0. So FA is 10 newtons according to the question. It's given as 10 newtons. So 10 into 0.5, that gives me 5 Newton meter, and that's also going to be clockwise. So coming to the third part of the question, that is O situated exactly at the middle of the two forces. Now if it is situated exactly at the middle of the two forces, the distance between FA and O would be half of 50. So half of 50 means 25 centimeters. And 25 centimeters, if we convert it to meter, we get 25 divided by 100. So that gives me 0.25. So what we do here is this FA into perpendicular distance between O and FA. So that happens to be 0.25. So I write it as FA into 0.25 plus FB into again 0.25 because O is at the center. It's written here O situated exactly at the middle of the two forces. So O is at the center. So this side will also be 25 centimeter. This side will also be 25 centimeter. And when we convert 25 centimeters to meters, it happens to be 0.25 meters. So we get it as FB into 0.25. So FA is 10 as it is given in the question. So 10 into 0.25 plus 10 into 0.25. So that happens to be 2.5. 10 into 0.25 is 2.5. Again 10 into 0.25 is 2.5. So 2.5 plus 2.5 gives me 5 Newton meters. And let us check out the direction. This is acting like this. So it will go the way my mouse is going for FA, as well as for FB it is going like this. So it will again go the way my mouse is going. So you can see both are clockwise. So we can write the direction as clockwise. Getting into the seventh question, exercise 1A, force, ICSE 10th. A steering wheel of diameter 0.5 meters. So the diameter of the steering wheel is given as 0.5 meter. You can see in the diagram here. Is rotated anti-clockwise by applying two forces, each of magnitude 5 newtons. So there are two forces which are being applied. One is, let's say, applied at the point B. I have taken it as B, so it is 5 newtons anti-clockwise. Another force that is applied at A, that is Fa, so this is again 5 newtons. Draw a diagram to show the application of forces. So I have already drawn it, you can see this. And calculate the moment of the forces applied. So for finding the moment of the forces applied, we can add the individual moments. So for this, that is Fa, it's going to be Fa into perpendicular distance between O and A, because the steering is always pivoted about the center or fixed about the center. So it's going to be Fa into perpendicular distance, that is OA. So I write it as Fa into OA, plus Fb into perpendicular distance, that is OB. So I can write it as Fb into OB. So moment of force is going to be 5, that is the value of Fa, into OA will be half of AB, because OA is nothing but the radius. If AB is the diameter, OA is nothing but the radius. And radius will always be half of diameter. So 0.5 divided by 2 gives us 0.25. So we can write it as 5 into 0.25 plus, again what's going to happen is Fb is 5 Newton into perpendicular distance is again 0.5 by 2. So that happens to be 0.25. So here we get 5 into 0.25 plus 5 into 0.25. So 5 into 0.25 gives me 1.25, and again 5 into 0.25 gives me 1.25. So 1.25 plus 1.25 gives me 2.5 Newton meter. And let's check out the direction. You can see Fa is acting like this, so it's going to act the way my mouse is going. So that is anti-clockwise. Again, Fb is acting like this, so it's also going to go the way my mouse is going. So this is again anti-clockwise. So since both the moments are anti-clockwise, we can write the direction as anti-clockwise. So getting into the 8th question, which happens to be a very important question from examination point of view and board exams point of view. So here a uniform meter rule is pivoted at its midpoint. So what will be the length of the meter rule? Meter rule is always going to be 1 meter. You have to remember that a meter rule's length is always 1 meter. A weight of 50 gram force is suspended at one end of it. So there is 50 gram force which is acting here at one end. We can consider any of the end. I have considered A. So we assume there is a 50 gram force which is acting at the point A. Now the question has asked, where should a weight of 100 gram force be suspended to keep the rule horizontal? Now we need to suspend a force of 100 gram force, and such that the meter rule is horizontal. Now there is a common sense thing here, that is, if 50 gram force is acting on the left side of the beam, 100 gram force definitely has to be on the right side of the beam for it to be balanced. So there is no way that you can actually put that 100 gram force anywhere here, because if you put it anywhere here, the rule obviously will go down on the left side. So in order to keep it balanced, we have to put this 100 gram force somewhere on the right side. So this is a total common sense thing which you should understand, and you should apply your logic there and do it. So 100 gram force definitely has to be on the opposite side. Now we know it is on the opposite side by now, but we do not know at how much distance it is. Now when will a meter rule be balanced? When the moment about the left side will be equal to the moment about the right side. So we can write, to keep the rule balanced, moment of 50-gram force is equal to moment of 100-gram force. So that is nothing but the moment about the left side is going to be, has to be equal to the moment about the right side. So what we do is, since it is in gram force, I did not consider converting it to SI unit. So I continued with gram force centimeter only. And the answer was also given in centimeters in the textbook. So 50-gram force is acting at a distance of 50 centimeters. So I write force into perpendicular distance as 50 is the force and this 50 is the perpendicular distance, is equal to again force into perpendicular distance. So here the force is 100-gram force and perpendicular distance we consider it as x because we do not know or we have to find out where it is acting. So this is going to be x. So I just solved this equation, that is take 100 to the other side. So we get 50 into 50 divided by 100. That's the value of x. 0, 0 cancels and 5 into 5 gives me 25 centimeter. So we can write the 100-gram force should be kept at a distance of 25 centimeter on the other side from the center. Or you can write, if you consider this as the 0 mark, this will be at the 75 centimeter mark because this is 50 and this is another 25. So 50 plus 25 gives me 75 centimeters. So you can write the answer in either ways. You can either write should be kept 25 centimeter from the center on the other side or on the right side, or you can write, if we consider this at the 0 centimeter mark, this will be at the 75 centimeters mark. Hope you guys have liked this video. Do share it with your friends. From the 9th question onwards, see you guys in the next video. Dhanyavad.